Hello and welcome to another free code session. My name is Jason Bach and I'm a little tired, but I wanted to keep plugging away a pony and maybe being tired to hit this section of pony is maybe not the brightest of ideas. But I want to keep moving on. I want to keep learning about this language and we start to actually write some code in it, like real code. But capabilities seem to be this thing in Pony that I see ISO and ref and other terms like that, and I don't really have any idea what they stand for or what they mean. And I've even read that this is probably I'll say maybe not the hardest thing in software development, but a concept that really takes some time to grok, to get into your head. And that's fine, but I really want to make sure I understand this. So we're going to dive into reference capabilities. So we did the basics, and yeah, I agree with this, that there aren't currently any mainstream programming languages that feature reference capabilities. So what is this? Built idea of the capability, do something. Yay. Usually that's something external researcher might ask it. Okay. That's an object capability. Reference capability. Object capabilities are about being granted. Reference are about denying you the ability to do things with memory references. For example, you can have access to this memory, but only for reading it. You cannot write to it. Okay. Our code will make Pony special. This is why I really want to pay attention to this section. There's a mathematical proof. Really? I'm kind of curious. What is this math? Fully concurrent garbage collection of actors on many core machines. I'm not going to go through this, but this is kind of actually interesting. Okay. And move that over here. It's type safe. It's memory safe. No dangling pointers. You don't want your pointers dangling. Sorry, that was a little immature. No buffer overruns. Has a concept of none, but not null. Exceptions safe. Yeah. We've heard that before. It's data erase free. Actually, this came up in one of the chats that Pony doesn't have locks or anything like that. Well, what does that mean? What do you mean by locks? Okay. Higher level concepts. Try to read through the chapter at least once. Don't worry if you struggle with them with first. It's any way of thinking about your code and takes a while to grasp. A real struggle. Yes. Really? There's resources on this? Sorry, this is not at the right magnification. Okay. Watch the video. Bang, hat, and arrow. Okay. Alright. It's not easy. This is something, though, that on one hand, I'm like, why does this have to be so complicated? On the other hand, there's two parts. One, I like the honesty, which is, this isn't easy. And two, programming is hard. There's truly nothing, especially if you want a language that has power and expressivity and performance. I do think that there's going to be some complexity that you just have to be willing to understand, and that's going to vary from language to language, but I think that's also in some ways it's necessary. In fact, I have over here, if I can grab it, one book that I actually do want to go through, as nuts as this sounds, which is this. Because I've never really spent the time to say how does... I mean, I've actually... When I was a senior in college, I was actually able to work on a project where we designed and had a chip fabricated. So that was kind of fun. But, you know, and I did some assembly programming when I was in college. But it's been such a long time, and I really want to understand, well, what actually happens on the chip. You know, we spend so much time up here that you need to know what's still happening. And then that's not just what scares me about people who work in JavaScript, but it also scares me about people working even C# or other higher level languages is, oh, it's just a machine. It's just there's a chip in there, and you don't really need to know or care what they're doing. It's like, well, yeah, but you do. I mean, if you really want to know how to make your car work to the best of its capabilities, is you have to know how everything works. And I don't. I just know I step on the gas and hit the brake and it works. I'm actually pretty ignorant when it comes to cars in terms of all the little details. And that's not a good thing. You know, the reason why cars like, well, some of the reasons why cars like F1 cars and other things that are so expensive is the maintenance, care, quality, and everything that goes into them is staggering. You know, but you have to have that level of precision and that level of detail. So anyway, I'm getting a little sidetracked. So we're going to talk about all this stuff about reference capabilities. Okay. Let's go back up here. Start with reference capabilities. So if the object is the capability, access rights in that object. Okay. Rights are part of a capability. Open a file in Unix and file the descriptor back. Designates an object, but it isn't a capability. To be a capability, we need to open that file with some permission, some access right. For example, open file and say you want read and write. I think that's what it's saying. Now we have a token and a set of rights. Component every reference has both a type and a reference capability. In fact, the reference capability is part of its type. Specify which of your objects can be shared with other actors. Allow the compiler to check that what you're doing is concurrency safe, sorry. So there are a few simple concepts you need to understand. Shared mutable data is hard. Yes. In fact, that's one of the things that if I ever do a review of client code, it's to see how many static fields and properties do you have. Static methods can be problematic, but not necessarily. But if you have shared, public static fields around, those are usually a sign of potential disaster for many reasons, and this is one of them. Is to use locks. Well, we know that locks can lead to deadlocks and all sorts of other problems. And it can cause performance hits too. Totally agree with that. Immutable data can be safely shared. Yep. One of the things that when I was learning about Project Rosalind is their emphasis on immutable trees. And there's definitely benefits to that. So, and one of them is this. And I've always thought of, if you do a code fix, you create a new tree. And that gives the code fix the ability, like in an IDE like Visual Studio, to see what are the changes that are being proposed. If you actually had access to the tree that's currently being displayed in the code editor, and you just change that, and it's mutable, well, now you're directly changing it. Maybe the user doesn't want the code fix. So, but that's one of many other, there's lots of other reasons why you want to do that. Isolated data is safe. Block of data is only one reference to it, then we call it isolated. Isolated data cannot be shared by multiple threads, so there are no concurrency problems. So only one of them has a reference to it at a time. Sorry. Ugh. And the data is still safe from concurrency problems. So a block of data has one reference to. It can be complex because the data may be a single byte, large data structure, with multiple references between the various objects in that structure. What matters for the data to be isolated is that there is only a single reference to that structure as a whole. Isolate some boundary of a data structure. A single reference outside the boundary that points to the object inside. There are a number of references inside the boundary, but none of them must point to an outside object. Okay. Every actor is single-threaded. Makes sense. If you understand the concept of actors, that's one of the tenets, the points of the model, is that single-threaded. So now you can send messages concurrently to an actor, but an actor will only work on one message at a time. Okay. So then you don't have to have like concurrency data structures or anything like that within the actor. Okay. Safely sharing data concurrently is tricky. How do reference capabilities help? By sharing only immutable data, isolated data, or whatever. Exchanging only isolated data, safe concurrent programs without locks. Very difficult to do that correctly. Accidentally hang onto a reference to some isolated data, you've handed over or changed something. I wonder if this is somewhat similar to Rust, with how they do like memory management. I'm not sure at all, but I'm wondering if this is at least in some ways somewhat similar, but who knows. I agree. Sorry for the yawning, but yeah, I don't think I'm going to do another episode tonight. I'm pretty tired. But anyway, I think I can concentrate for 30 minutes. Type qualifiers. Use C++? No. Well, that's not true. I did C in college, and I did C++ on a project once in 2001, and I did it because it kept me billable as a consultant. But I said, I don't want to be on a project where we have 20 different versions of a string and everybody's doing all their other stuff. And we actually ended up doing, I could actually be a C++ program in their project because we were very clean with what we did. But I don't remember anything from it. I'm like, whew, that's like so far gone. Const, which is a type qualifier, not to allow the programmer to mutate something. Okay, yes, yeah. I think I know what that is. Reference capability is a form of type qualifier. Provides a lot more guarantees than const does. Every use of a type has a reference capability. Its capabilities apply to variables, rather than the type as a whole. In other words, when you define a class wombat, you don't pick a reference capability for it. Instead, wombat variables each have their own reference capability. As an example, in some languages, you have to define a type that represents a mutable string, and another type that represents, well, not in C#, strings are immutable. So, well, okay, nice saying there's a string and a string builder. Yes, there is also a, there's a similar, I thought it was string builder in C#. That's what's throwing me. It's like, I thought it was a buffer in Java, but never mind. In Pony, you can define a single class string as some variables that are string ref and other variables that are string val. Right. I thought let was immutable. Going back variables. Var is mutable or let is immutable. Yeah, it's the other way around. This is kind of confusing me. I thought a variable var is mutable or let, and it's a val. Okay, I'm a little confused by that. A list of reference capabilities. There are 6. ISO, references to isolated data structures. If you have an ISO variable, know there are no other variables that can access that data. So you can change it however you like, give it to another actor. Value, val, immutable data. If you have a val variable, then you know that no one can change the data. So you can read it and share it with other actors. Oh, isolated is not immutable because you can change it. Okay. Ref. If you have a ref variable, you can read and write the data however you like, but you can't share it with other actors. Box. That data might be immutable and shared, maybe other variables. The box variable can be used to safely read the data. Write code that can work for both val and ref variables as long as it doesn't write to the object. Transition, trun. Data structures that you want to write to while also holding read-only box variables for them. This is for references used only for identification. You can either read or write data using a tag variable. But you can store and compare tags that check object identity and share tag variables with other actors. Note that if you have a variable referring to an actor, then you can send messages to that actor regardless of what a reference capability that variable has. Reference capability comes at the end of a type. So for example, string isolo transitions from reference value by. What does it mean when a type doesn't specify reference capability? It means you're using default reference capability for that type, which is defined along with that type. Here's an example for the standard library. We use a string. We usually mean a string value. And if I remember what it just said, immutable data structure. So do I have to specify a reference capability when I define a type? Only if you want to. There are sensible defaults that most types will use. There are ref for classes, val for primitives, and tag for actors. Okay. When you write a constructor by default, that constructor will either create a new object with ref or tag as a capability. In the case of actors, the constructor will always create a tag. For classes, it defaults to ref. I think it means it defaults to ref. But you can create with it. So, ref is a class. No, when you call foo create 1, you get a foo val instead of a foo ref. Or you would create both val and ref foos. You can do something like this. Two different constructors with two different capabilities. So depending on what you really want to do. Better user capabilities, recovery facility opponent that we'll cover in the recovering capabilities section. Because this wasn't an actor, this was a class. And how do you create actors again? Oh, that's right, they have behaviors. That's right, they have behaviors. Bees. All right, let's just check this out. Right, so we have all those recovering capabilities. Yeah. Wait, how did... Oh, it's down here. Let's keep going in order. Okay, so let's actually look at reference capability guarantees, and then I'm going to bed. So those types are guarantees. In terms of what's denied, what can other variables not do? We need to distinguish between an actor and the variable in question and other actors. Data reads and writes from other actors may occur concurrently. Two actors can both read the same, right, because they can only work one at a time, but they could be at the same time. Same data, one should change on the, yeah, need for locks, blah, 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 blah. All code with any actor always executes sequentially. Yes. Means data access for multiple variables within a single actor do not suffer from data races. Immutable reference capabilities are ISO, because you can, as long as you're within the isolated boundary, trin and ref. If an actor has an ISO variable, no other variable can be used by any actor to write to that object. It means an ISO. Variable is the only variable anywhere in the program that can read or write, can write to that object. But other variables held by the same actor may be able to read from it. It is write unique. Ref variable, no other variable can be used by other actors to read from or write to that object. Read from or write to the object, but only from within the same actor. because they'll stop other actors from reading from or writing to the object. Or our data races. Our valent box. No other variable can be used by any actor to write to that object. What were these again? Can't ever change, is globally immutable. The box variable, no other variable can be used by other actors to write to that object. Locally immutable. It's funny because boxing is kind of a different thing in .NET, I think. Why can't they be used to read but not write? Tag. A tag variable makes no guarantees about other variables at all. As a result, it cannot be used to either read from or write to the object, hence the name opaque. It's still useful though, that you can do identity comparisons with it, you can call behaviors on it, and you can call functions on it that only need a tag receiver. Why can't tag be used to read or write? Because tag doesn't stop other actors from writing to the object. That means if we tried to read, we're no guarantee that with some other actor, we might get a race condition. How long is this section? Short. Okay, then I'll stop. Consume and destructive read. I'm done with this thing. 2 means of handling situation. I will admit I understood that they said that there's going to be very little code examples in this, but examples would help. So, yeah. Sometimes you want to move an object from one variable to another. You want to make a new name for the object. In other words, you want to make a new name. You want to move the object from some existing name to a different one. Consume. Consume. Reminds me of They Live from John Carpenter. When you consume a variable, you take the value out of it, effectively leaving the variable empty. No code can read from that variable again until new value is written to it. Consuming a local variable or parameter allows you to make an alias with the same type, even if it's an ISO or a trim. For example, function A wombat, which is an ISO. Variable B, which is a wombat ISO, you consume A. Because by consuming A, you said that the value can't be used again. The compiler will complain if you try to. Try to assign A to C. Can I consume a field? Definitely not. Consuming something means it is empty, that is, a no value. There's no way to be sure no other alias of the object will access that field. If we tried to access a field that was empty, we would crash. Destructive read. To move a value from one name to another. Earlier we talked about how Simon and Pony returns the old value to the left-hand side, rather than the new value. This is called destructive read, and we can use it to do what we want to do, even with fields. So we have a class with a wombat. We do a new. We cover wombat end. I guess that's a destructive read. Function ref, capability out, wombat in, var b, wombat ISO is equal to buddy, which is consume of A. That's allowed. Why is that allowed? Because you can consume A, assign it to buddy, the old value of buddy to B. We have fields when we can't consume them. Because when we do destructive read, we assign to the field so always has a value. Unlike consume, there's no time where when the field is empty. That means it's safe and the compiler doesn't complain. Wow. Yeah, I'm not going to get into this one tonight. I have to admit, yeah, I can see where this is something that probably takes a while, because I really don't get this right now. I really don't. I don't. Yeah, I can't even say that I kind of get this. Seeing examples that really push this, I think, would help tremendously. The more when I read this and said, this, I'm like, no, I don't. I really think they should have had examples with these, because, wow, it's going right over my head a little bit. But that's okay. That doesn't mean just abandon it, because apparently this is something hard to understand. So that's it. I was going to do another episode on something I'm working on with rocks, but I am just brain dead at this point, and I really just need to go to bed. So, with that, I'm going to stop. Thank you all for watching. Leave comments and questions below. See you in the next episode.